Welcome to Algebra Section 7.7, the mixture problems. Today we will be setting up two problems explaining mixture problems, but they will not be completely solved. We'll just fill in the charts and set up the equations. We'll begin with the first one. A grocer makes a natural breakfast cereal by mixing oat cereal costing $2 kilograms with dried fruits costing $9 per kilogram. How many kilograms of each are needed to make 60 kilograms of cereal costing $3.75 per kilogram? You'll note that I already have a table listed here, and this first box in the table we will not fill in just as we have done previously this year. When we're looking at this table, we have to look at the example and determine what we are looking at and what we mean. When I read the first sentence, I notice I have an oat cereal, and it has a cost, and there's a weight associated to it. So I'm going to put in my first box the oatmeal cereal, and I note that there is an amount that I'm going to mix, and it's in kilograms, so I have that noted. My second one I note I have is money, so this is the cost per kilogram. And then when if I've purchased a certain amount of this oat cereal, and I know it costs me $2 for every kilogram, I know if I multiply these two things together, I will end up with the total cost. So when I look at the next thing, continuing, it says I'm going to take that dried cereal, that oat cereal, costing $2 a kilogram, with dried fruits. So I'm going to include some fruits in there, and those cost $9 per kilogram. And then my final sentence says how many kilograms of each are needed to make 60 kilograms of a cereal costing $3.75 per kilogram. So I'm going to take the oats, and I'm going to take the fruits, and I'm going to mix them together into our new cereal. That new cereal is going to cost $3.75 per kilogram, and I want 60 kilograms of it. So I have my 60 there. Now you'll notice just by reading the problem we were able to fill in 4 of the boxes. We have 2 boxes here that I still need to come up with a value, and then we'll be able to calculate the last 3 boxes. So when I look at my oats and my fruit, I see I have to have a total mixture of 60. I do not know how many oats I'm going to use, so I'm going to call that X. I do know that I need 60 total kilograms. And if part of that is oats, I would have to take 60 and subtract however many oats I'm using to come up with my fruits. Now that I have that filled in, I'm able to calculate my final column. This becomes 2x. 9 times the quantity, 60 minus x. And then in the last one, 375 times 60. Now that I have all of my boxes filled in, I'm going to go back and look and see what exactly are they asking me to find. I need to know how many kilograms of each are needed to make this cereal, costing $3.75. Well, I have to remember over here I have my oats and fruits, and I said I was going to mix them together. So that would mean that I'm going to add them in order to come up with my mixture. Well, if that is the case, then I can use my final column right here to come up with an equation. So I can have the cost of the oats added to the total cost of the fruits, and that will equal the cost of the new mixture. Now, with that written in English, I'm going to apply my mathematical items from my chart. So the cost of oats is 2x, plus the cost of the fruit is 9 times the quantity, 60 minus x, and that equals the mixture's cost of 375 times the quantity, 60. That would be your final setup for your equation, and you can solve from here. Moving on to example number 2. How many kilograms of water must be evaporated from 12 kilograms of a 5% salt solution to produce a solution that is 30% salt? Once again, we'll begin by blocking out that first block of our chart. We will not be using that. And just like the last one, we have 3 columns across the top, which I will label. When I look here, I see that I have 12 kilograms of a solution, so I have an amount in kilograms. And then here and here, I notice that I have a 5% and a 30% salt solution. So this is going to represent percentages of salt. Okay. And then over here, taking both of these, just like the last one, multiplying it together gives me my total percentage. Now when I look, I see that I have the original 5% solution. There is going to be a new solution. I place that in the bottom box. And I have this missing piece right here. It says how many kilograms of water must be evaporated. So I'm going to be removing the water. So this is going to represent water. So I have everything labeled and I'm ready to start filling in my boxes. I'll start reading and filling in. How many kilograms of water, I don't know, so I'll call it X, must be evaporated. That tells me I'm going to subtract from 12 kilograms of a salt solution to produce a solution that is 30% salt. So this is my 5%, this is my 30%, just from reading that problem. Now I'm going to look, I have 4 boxes filled in. I have 2 that I still need to fill in. So when I look here, I have a 5% solution, and I'm going to evaporate the water to come up with a 30% solution. Evaporate means subtract. So I'll have 12 minus X. Over here, my title tells me I have percentage of salt. So when I look at that water, that percentage is 0%. And then I can calculate each of my final boxes. So 12 times 0.05. The total for water will be X times 0. And for the 30% solution, 0.3 times the quantity, 12 minus X. Now, once again, we have to set up our equation. Our equation will come from this last column here. So I'll have the 5% solution. I will subtract the water that's been evaporated. And then I'll be left with my 30% solution. Using that as my guide, I will replace each of these from my chart. So 12 times 0.05 minus X times 0 or 0x, and 0.3 times the quantity 12 minus X. From here we have the problem set up and the chart filled in. You should be able to complete that problem. Thank you for watching.